So we know the integrals of sine is negative cosine, and the integral of cosine is sine. So let's learn a few more trig integrals. The integral of tangent x is negative ln of the absolute value of cosine x plus c, or the natural log of the absolute value of secant x plus c. The integral of cotangent x dx is the natural log of sine x plus c. The integral of secant x dx is the natural log of secant x plus tangent x plus c. And the integral of cosecant x dx is negative natural log of cosecant x plus cotangent x plus c. So now let's consider strategies for dealing with secant and tangent. So we're going to raise tangent to the n power, secant to the n. And if n is even, so if secant is even, we're going to split off as secant squared. And then we're going to rewrite the remaining even powers of secant in terms of tangent, and we'll let u be equal to tan x. If m is odd, so if the power of tangent is odd, then we're going to split off as secant tangent, rewrite the remaining even powers of tangent in terms of secant, and then we'll use u equal to secant x. And once again, if we have both n being even and m being odd, you can pick either one of these methods. And in the other case, if m is even and n is odd, then we're going to rewrite the even powers in terms of secant, and we're going to use the reduction formula for secant. So let's start with this one. So in this case, we have an even power on tangent and an odd power on secant, so we'll be in our third case. So I'm going to have to rewrite this tangent. So we have the identity that tangent squared is secant squared minus 1. So this is secant squared x minus 1 squared times secant cubed x dx. Once this is simplified, we have secant to the 7th x minus 2 secant to the 5th x minus, or plus rather, secant cubed x dx. And so now we're going to have to use the reduction formulas. So we'll start with this secant to the 7th. The reduction formula says that this is secant to the n minus 2, so now secant to the 5th x, tangent x, over n minus 1, so over 6, plus n minus 2, so over 5 over 6, times the integral of secant to the 5th x dx. So keep in mind, this is just the integral of the secant to the 7th. We'll now reduce this one, 5 over 6 times. This would be secant to the n minus 1, so n minus 2, so secant cubed x tangent x, over 4, plus n minus 2, which would be 3 over 4, times the integral of secant cubed. We'll now go ahead and reduce this one here. This would be secant to the n minus 2, so we just have secant x tangent x over 1 plus 2 over 1 times the integral of secant x dx. So now I can use all of this to find my integral. So my actual answer is secant to the 7th, so we have all of this, minus 2 secant to the 5th plus secant cubed. So this term right here is the integral of secant to the fifth. And this one right here is the integral of secant cubed x. So this is really going to help us out. So I'm going to start with this first term. Secant to the fifth x, tangent x over 6, plus. So now I have 5 over 6 times secant to the fifth power, or times the secant to the fifth power. And then I also have this minus 2 times the integral of secant to the fifth power that comes from here. So 5 over 6 minus 2 is going to be negative 7 over 6. So I have minus 7 over 6 times secant cubed x tangent x over 4 plus 3/4 times the integral of secant cubed. Well, I have a 3/4 secant cubed coming from here, along with another 1 coming from the secant cubed. So in reality, I'm going to have the 5 over 6 secant, So from the secant to the 7th, I have 5 over 6 times 3/4 times the integral of secant cubed. So that's 5/8 times the integral. From this negative 2 times secant to the 5th, I'm going to have a negative 3 over 2 times this integral, and then plus 1 from the actual integral, which is going to end with 1 over 8 times the actual integral of secant cubed, which is secant x tangent x plus 2 times the integral of secant, which we know is ln, times the absolute value of secant x plus tangent x plus c. Let's do another one that's a little simpler. In this case, the power for tangent is odd, and the power for secant is even, so you can use either one of our two formulas. I'm going to use the first one, which says that we'll break off a secant squared, and then we're going to use this substitution u is tangent x. That makes du equal to secant squared x dx. So this is now the integral of u cubed du, which is 1 over 4th u to the 4 plus c. So 1/4 tangent to the 4th x plus c.